Hello, Algebra and Honors Algebra students. Mr. Lawrence here, and here's that follow-up video for multiplying rads. Okay, now, a lot of you are pretty smart, and you know that like rad 5 times rad 10 is rad 50. But I am personally not going to do the problem that way because I hate doing something and then having to later undo it. It's like extra work. So I am going to think about rad 5 times rad 10 as rad 5, the rad of 5 times 10, like that. But the reason I'm not going to put them together and say 50, I know I'm just going to have to break it apart. And I know that a factor of 10 is 5. And so I'm going to think about it like this in my head. 5 times 2 under the rad. Whereas this 5 times 2 is coming directly from the 10. Well, why would I do that? Well, because I've got a perfect square sitting right there. I've got a 25, right? So now what I have in the problem is I have the rad of 25 times the rad of 2, which is 5 rad 2. And I'm done. Okay, because I can't break down rad 2 anymore. If I have a situation like number 2, it's a distribution situation. I'm going to distribute and like that. And I'm going to multiply coefficients by coefficients and then rads by rads. Well, in this first problem, first part of the distribution, I'm going to think about it as the rad of 3, right there, times the rad of, and I'm not going to do 6, I'm going to do 3 times 2. And that'll be minus, now the coefficient out here is 1, so that'll be minus 4 out front. And then under the rad, I'm going to have a 3, and times a 3, and then times a 4. Ooh, that's interesting. Look what's going to happen. Do you see it? Now, here I have a perfect square, 3 times 3, right? If you want, I can actually just skip a step here. I can call this 3 rad 2. Okay, if that bothers you, here I'll put the baby step in, no problem. I'll put that baby step right in there. I said this was the rad of 9, 3 times 3 is 9, times the rad of 2. And so you see the rad 9 turned into a 3 coefficient. Okay, now over here I'm going to have minus 4, and then I'll have a rad of 3 times 3 times a rad of 4. All right, so that means I'm going to have 4 times 3 times 2. So that looks like that would make negative 24 plus 3 rad 2. And some of you are probably wondering why I changed the order. Remember, we always write the rational number before an irrational number, so it never mistakenly enters under the rad symbol. So there is the simplest version of my distribution. Okay, why don't you try numbers 3 and 4? Unpause the video when you're ready to see my solutions. All right, here we go with my solutions. If you haven't tried them on your own, go ahead. So I'm going to distribute here and here. And so I'm going to do 2 times 3 and get 6. Now I'm going to have a rad 7 times a 7 times a 2. Right? And so that's going to be 6 times 7 rad 2, or 42 rad 2. And I've only done the first multiplication. Now I'm going to come over here to this one, and I'm going to have 10, and then I'm going to have a rad 7 times a 7 times a 4, which is going to be 10 times 7 rad 4, but rad 4 is really 2, and so that looks like it's going to be plus 140. My best answer will be, I really should have equal signs along the way here. My best answer will be 140 plus 42 rad 2. Okay? All right. So if you haven't tried number 4, again, go ahead and try it. So I'm going to have 12 from the 6 times 2. Now under here, I'm not going to, yeah, I can. I'll go 2 times 2 times 3. And so that'll be 12 times 2 rad 3, or 24 rad 3. Now for this part, I'm going to get a 24 when I do 6 times 4, and then I'm going to get a rad of 2 times 3. Well, there's no factors there that match other than 1. There's not going to be a perfect square other than 1. So I'm not going to have a middle step, and I'm just going to go 24 rad 6. I have a question for you. Does this equal 0? Does it equal 0? And of course, you should know the answer that no, it does not equal 0, because these are not like terms. There's 24 rad 3s, but there's 24 rad 6s. Rad 3s and rad 6s are not the same. All right, real quick, I want to mention, like when we multiply, say, rad 5 times rad 5, I'm hoping that by now you're starting to realize that that's the same as this, which is the same as this, which causes these exponents to cancel out, and boom, the answer is 5. Now, I don't want to go through all those baby steps, but I'm very surprised that some of you, if I give you rad 11 times rad 11, you go, okay, well, let's see, that's rad of 121. Square root of 121 is 11. I'm expecting you by now to just see 11, knowing that squaring a rad cancels out the rad, cancels out the root. Okay, so if I have, say, 5 rad 7 times 4 rad 7, well, I'm going to get 20. But then this is going to get me 7. So my answer is going to be 140. You ladies and gentlemen are intelligent enough, you should be able to do that really quick. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.